Hello everybody and thanks for joining my presentation. My name is Smpte and I'm part of the Enterprise Market Development team at Mellanox Technologies. In the next 30 minutes I'll present how easy it is and why you need to design and deploy accelerated computing systems over open networking solutions. I have only 30 minutes. It may not be enough to go deep dive in a couple of the slides that I have. So after the presentation, I'm going to be in our virtual booth. So hopefully you can join me there and then we can discuss the questions and topics that you may have. Question is, let's start why and what it is accelerated computing. And it's everything about the workloads themselves. There are new workloads in the market that requires a very high performance that the CPU cannot provide today, the traditional, I would say, CPU. One of the example, and probably the most popular one, is the machine learning on deep learning. Yes, you can still do it on the traditional CPU, but it's going to take forever, so good luck. But this is where you need actually GPUs to do the job. The GPUs are designed to run those specific workloads. Another example is the security workloads. Everybody that builds today a new data center, and even in the old one, needs to run specific tasks to protect the data center. So very popular ones are the encryption, decryption. You run it over the CPU. Yes, you can run. The question is how many you can run at the same time, at what speed. But in any case, it's going to take you more than 30% of the CPU cycles that are needed actually to run the applications themselves. Many other and few other, I would say, areas that are performance sensitive is the NFV and edge computing. Specifically, they are sensitive from the latency point of view. They need to meet a specific timing requirements, and if you are not meeting the requirement, then it cannot be done. The last example that I decided to use is actually the video over IP. It's a new standard called the Smpte 2110. This is a standard that enables video over IP solution for high resolution, more than even 4K. And in those cases, you need to meet a specific timing requirement, very accurate, and doing it on the CPU itself, a protocol called PTP, if you're familiar with, you still can do it, but it's not going to be as good as the one that you can do it in the hardware itself that the modern or advanced NICs have as an offload. If you will take all of those workloads and add to huge amount of data that is required to support them, example, machine learning on the training side, there is so much data, more is actually better, then you can fine-tune the algorithm or the model better. Then you can understand why the CPU of today cannot handle anymore those workloads in an efficient way and needs some help. And the help comes with offloading specific tasks from running of the CPU to run on subsystems. It can be the networking, it can be the GPU, it can be other method, but the offload is needed here. One of the most, I would say, very well-known offload is the RDMA. RDMA is the remote direct memory access that offloads the networking from I would say workloads, the transport from running on the CPU itself to run on the NIC. Instead of running, for example, the TCP/IP, you can do it. It's a stateless offload. There is no reason why not to do it. This is something that Mellanox has been doing for the last, I say, the beginning of the company about 20 years ago. Very mature. And if at the beginning it was only part of the InfiniBand networking standard, now it's part of the Ethernet in a protocol called RoCE. And for that, instead of me describing, let's see this nice video that explains the benefits of doing it.
Meet Jeff. He's the data center architect at Faster Enterprise. Jeff's servers have to handle massive amounts of data for analytics and have 100% uptime. Over the years, with the adoption of server virtualization, big data analytics, and proliferation of mobile devices, the corporate citizens of faster enterprise have noticed that applications are taking longer than they should to execute. And when the corporate citizens experience slowing in the system, they become less productive. The delay is happening because large amounts of data have to move between servers of faster enterprise. This data transfer is being handled by the CPUs, which causes other tasks to slow down. One solution to solve this performance problem is to add additional servers. However, this would blow Jeff's budget. Jeff could use RoCE. RoCE is RDMA over Converged Ethernet. What does this mean? Let's begin with RDMA. Remote Direct Memory Access is a technology that allows data to be transferred from one machine to another with much less work being done by the CPU. This frees the CPUs to do the work that they're meant to do, such as run applications and process massive amounts of data. And RDMA over Converged Ethernet means that Jeff can gain the benefits of RDMA without the need to replace his Ethernet infrastructure. After adding RoCE adapters to his data center, Jeff has significantly increased the speed and power of Faster Enterprise's data centers while lowering his total cost of ownership. And as Faster Enterprise grows and finds it necessary to build additional data centers, Jeff can take advantage of end-to-end implementation of RoCE and experience the highest performance gains. The InfiniBand Trade Association's RoCE initiative provides RDMA over Ethernet education, reference solutions, and resources to data center managers and architects. Visit and explore the RoCE initiative website to learn how RoCE is powering the future of enterprise data centers.
So after you saw the video about the benefits, I just want to spend a couple of slides to show the performance boost and the efficiencies that you are getting on the application level. I choose a couple of them. The first, there are again many, but I choose a couple of them. The first one that I choose is the NFS, which is one of the most common file systems that very popular, as you may know. And it's pretty much double or more in all parameters. So it's not just on the low level, but also the application level. You see the benefits, specifically if it has to do about moving data from one place to the other. On the bandwidth point of view, you can run up to 200 or 2x performance compared to the TCP/IP. Yes, you can still do it on the TCP/IP, but RDMA give you much higher performance, and the same about operation per second. So this is one of the examples. The other examples that I want to use is like the machine learning. You can run machine learning in a bare metal. Probably it's going to be the best way for you to get the highest performance, because when you're running in a virtualized environment, of course, the ease of use takes some performance because of the hypervisor involvement. But if you can live with it, then it's a very convenient way to do it. Up to recently, it was not very efficient. The TCP/IP was too slow. But at the end of last year at VMworld 2019, we did it with a couple of partners of us, the VMware and NVIDIA, and we showed that if you are using the RDMA offload and the GPU offload in a virtualized environment over vSphere that support VM to VM over a mode called PVRDMA, you can pretty much double the performance. So again, in the machine learning deployment, in a virtualized environment, you still get a pretty good performance, not as good as my bare metal, but pretty close to that. And this is in a virtualized environment I want to emphasize, and not in SRIOV. In SRIOV, you will get pretty much the same as a bare metal. So this is what is we are getting, and just to explain what is going on, it's very easy to probably to understand, so I wouldn't spend too much time on this slide. On the left side, you see a CPU that still run the transport without the offloading. So a lot of the cores depends on the speed, depends on the protocol, depends on how strong is the CPU is, but pretty much you can assume that if you're taking one CPU, probably half of it may be involved on running the transport itself instead of running the application that this is the CPU needs to do, compared to the other side that all the cores, because the CPU offloading it to the I/O and tells the I/O processor, move this block from this place to the other, tell me when you are done, and pretty much about 99% of the core are available to run the application itself. So this is a great example, and this is why we see the Rocky everywhere in any data center. If in the past it was just in a niche market, today you can see it on bare metal, virtualized environment, virtualized machine, or containers, overlay, whether it's VXLAN or Genève. And another thing that I would like to mention is that if up to recently you had to run Rocky over lossless fabric, and you had to program the switch to make the fabric lossless using priority flow control or ECN, you don't need to do it anymore. Mellanox released a technology called Zero Touch Rocky, or in short ZTR. It's all about the acronym in the high-tech industry, as we know. And that you can run the Rocky over lossy environment. Again, today you can run Rocky over lossy environment the same way that you are running the TCP/IP. There is no difference between the two of them, and the benefits of running Rocky is very well demonstrated, and there are again hundreds, if not thousands, of examples why Rocky is much better. So again, our switches and our NICs can support both. There is no, it's not instead of, it's in addition to, and they are coming with both capabilities. But wherever you need higher performance, higher efficiency, resiliency, probably Rocky is the way to go. We published several benchmarks showing the benefits, showing the performance boost that you are getting. In this particular case, we ran the Microsoft Storage Spaces Direct, Microsoft S2D, compared TCP/IP, ZTR, and also lossless, which is using the priority flow control and the ECN. You can see a very little degradation in the performance compared to lossless and lossy with ZTR, but much better performance than the TCP/IP. So again, I would encourage you to dig into using Rocky. It's available today without configuration, very easy to use. And if you have more questions, just ping me after the presentation. I just gave RDMA as one example for offload. There are many other examples that you can do a stateless offloading, including security, including NVMe over fabric, including all kind of offloading that you don't need to use the CPU. Many of them we already have in our latest ConnectX-6 DX. This is the latest NIC that we announced. So instead of me again presenting each one of the features, please watch the video, and later we can discuss and deep dive.
The exponential growth of data is driving data centers to increasingly rely on powerful networking to stay ahead of the competition. If you thought building a secure and efficient data center was mission impossible, think again. Introducing Mellanox ConnectX-6 DX, the latest superstar of the award-winning ConnectX family of network adapters. The goal is to turn mission impossible to mission possible. In other words, to accelerate mission-critical applications with best-in-class data center security, maximum performance, and efficiency, all while saving money and power. Our special SmartNIC agent has special powers, industry-leading 50 gigabit per second PAM4 SerDes technology, offering speeds from 25, 50, 100, and even 200 gigabits per second, which helps him accomplish his mission. Best-in-class data center security capabilities, together with the most advanced networking accelerations and innovative Rocky capabilities. Data center security is enhanced with ConnectX-6DX, as it provides purpose-built engines that offload IPsec and TLS data in motion, as well as XTS AES data at rest cryptographic operation from the host processor. IPsec and TLS accelerations are key to enabling secure data center communications and web application delivery, while the XTS AES data at rest encryption offload enables efficient storage encryption capabilities. By offloading these cryptographic operations, our ConnectX-6DX SmartNIC frees up the host CPU for money-making applications and uniquely enables encrypted traffic to benefit from all the other advanced networking offloads it offers. Without the inline hardware crypto engines, these accelerators would otherwise be rendered useless when presented with opaque encrypted payloads. Furthermore, equipped with hardware root of trust and support for RSA-authenticated secure firmware update and secure boot, ConnectX-6DX also guarantees the security and integrity of critical data center infrastructure. When it comes to network virtualization, ConnectX-6DX delivers the highest flexibility and performance at extreme scale. By leveraging the high-performance ASAP² advanced switching and packet processing hardware accelerations and offload open vSwitch data path forwarding from the host CPU to the adapter's ASIC. This frees the packet processing from the x86 CPU, resulting in both improved performance and better application efficiency. The built-in SR-IOV and ViRT-IO acceleration engines enable high bandwidth and a low latency network interface that's ideal for compute and storage platforms. In addition, ConnectX-6DX supercharges stateful firewalls by accelerating OVS connection tracking with advanced ASAP² technology. As the world's leading Rocky adapter, ConnectX-6DX enables scalable, resilient, and easy-to-deploy storage, big data, machine learning, and artificial intelligence solutions. Delivering zero-touch Rocky with extended programmability options, ConnectX-6DX allows RDMA transport to run seamlessly on existing Ethernet fabrics without requiring any special network configuration. ConnectX-6DX advanced NVMe over Fabric offload capabilities also make it the NIC of choice for storage workloads. Simply put, ConnectX-6DX is the finest SmartNIC available, making the impossible possible by delivering new levels of security and efficiency with the highest return on investment for scalable cloud fabrics, enterprise, telco, and SDN NFV data centers. Mellanox ConnectX-6DX, a proud new member of the award-winning ConnectX SmartNIC family.
So offload engines, stateless offloads are very nice, but the industry wants more. The industry actually started to push for more functions to be offloaded, not just stateless, but stateful as well. Not just to save the CPU cycles, but also to come with more robust. And actually we started to see the need for I/O processing unit, not just as a passive NIC, but a NIC that can actually process data and run compute on the NIC itself. So not just offload the CPU and GPU, but also to run specific functions on the SmartNIC itself. And this is why we came with a solution that includes both of them. And this is our Bluefield. And this is the only solution that is available today in the market that includes both the NIC and integration of the most advanced NIC in the market. In our case, it's the ConnectX-6DX and a bunch of ARM cores that on the ARM cores themselves you run the compute. It's a little, not little, but it's different from what the market is doing today, and because we believe that if you want to run I/O on a NIC, the NIC is the best way to do it, but if you want to run the compute, this is why you have the cores themselves, and we don't want to run a typical I/O function on ARM cores because it's not going to be as efficient, it's not going to be as fast as using the NIC itself to do it. I didn't mention, but both of them, the ConnectX 6DX and also the BlueField 2, are also available on OCP version, the OCP 3.0. We can discuss it later when we'll meet in our virtual booth. The NIC itself, the NIC itself is the same NIC that we are running on the ConnectX 6DX, the same function. The BlueField enable, as I mentioned before, ARM cores as well. And this is actually the block diagram of the newest ones that we are just going to deliver to the market. It has up to 8 cores of ARM72. Each one of them can run off 2.5 gig. There is the ConnectX 6. There are the cores. There is the PCI switch. PCI by the way, Gen 4, 16 lanes. It can do regular expression. It can IPsec, TLS. Everything that I mentioned before or you saw before in the video, and it can support Ethernet and InfiniBand, what we call a VPI, Virtual Protocol Interconnect, so you can do both of them. So it's pretty much very, very flexible device. And if you go into the use cases, you can find a way to offload any, I would say, in any area, whether you want to do the storage, we have the NVMe over Fabric, we have the emulations that you saw before, security, machine learning, edge computing. It's pretty very flexible device that you can do. You can design the best solution for your need. In order to understand a little bit more about it, please watch the video and I'll meet you after that.
In the last decade, we've seen an explosion in the amount of data that is consumed, shared, and analyzed. All this data needs to be transported across networks in a fast, efficient, and secured manner. This exponential growth has overloaded CPU resources, and that led to poor application performance, slow I/O processing time, and expensive scaling costs. To meet these new requirements, data centers should transition from a CPU-centric to a data-centric architecture. If you thought this was an impossible mission, think again. Mellanox introduces the BlueField-2 I/O processing unit that frees up host CPU resources and accelerates networking, storage, and security in real time. BlueField-2 moves the compute function closer to where data resides, and as such is a perfect solution to empower cloud, edge computing, and AI applications. BlueField-2 provides 2 ports of 25, 50, or 100 gigabit per second Ethernet and InfiniBand connectivity, or a single 200 gigabit per second port. BlueField-2 Silicon integrates the ConnectX 6DX best-in-class network adapter and its hardware accelerators together with an array of ARM cores to enable software-defined networking and storage programmability with a fast memory interface. With all these advanced tools in its arsenal, BlueField-2 is ready to accelerate and secure diverse solutions that can be developed based on it. Here are just a few. Mission 1. Disaggregated storage. BlueField-2 IPU virtualizes hardware storage resources on the client side, so they appear as if they are local, and enables storage to be part of a composable infrastructure to deliver huge CapEx and OpEx savings. Cloud service providers can virtualize bare metal storage with no impact on their customers. Mission 2. Provision bare metal as a service. In bare metal use cases, Bluefield 2 allows the operator to provision bare metal as a service to the cloud tenant while still implementing service provider policies to preserve control and visibility and protect the server environment. Mission 3, micro-segmentation. Bluefield 2 IPU enables enhanced visibility and micro-segmentation policy enforcement on every endpoint. Agents are integrated into Bluefield 2, fully isolated from the application workload, while also complying with strict regulations and embracing DevOps automation. Bluefield 2 IPU is a new class of coprocessor that offloads the CPU and improves efficiency by delivering high performance, programmability, and security to answer the data-centric architecture challenges by freeing CPU resources securely and efficiently while maximizing return on investment, and changing the game to make what was once thought impossible, possible.
Again, so now when you have the smart NIC like the ConnectX 6DX, and you have the programmability on our Bluefield, the I/O processing unit, it's not just about offloading the transport, but you can offload all kind of other stateful functions like the encryption, the deep packet inspection. So the overall, you see, it's much more efficient, and you are, instead of running and using CPU cores to run it, you are getting again the same as we were getting before, and the CPU is doing its job, what is best to, and all the other can be offloaded to the specific engines that are available there. Again, let's this is pretty much, I believe we are at the end of the 30 minutes. So again, we are providing end-to-end open InfiniBand and Ethernet solutions. We have all the components that you need, from NICs, cables, switches, software. Hope that you enjoy the presentation and come to see us at the booth and discuss it. Thank you very much for attending.
Hey guys, it's Smpte. I don't know if somebody is online. I see a couple of guys are on the chat box. But if you have more questions, first I'm going to be later in 3 minutes on our booth, so we can continue to chat there. We have another 2.5 minutes here. But if somebody is online and dialed in on the voice side, I'll be able to answer any questions that you may have.